Well, this is gonna be much more of my we could kind of things that I'm not really good at. But I'll still give it a shot. Alright, I forgot to keep the pop-up chat. Alright, we should have also chat working. Everything seems fine. Let's begin. So I've only got 3 problems. I think this is the more difficult one. Let's just try and figure this out first and then we'll work our way up. Implementing pow percentile d. In other words, in a given x, n, and d, you have to find x to the power of n percentile d, x such that x to the, so I have to do basically the implementation of a recursion function which is a power based. Alright, what are the constraints? Constraints have not been given. What do I know about this? Okay, so power function. So we know in the power function we have to like say if I is equal to 0, we have to return 1. Alright. Now that's the ending condition. Else we have to just say, can we do this? Actually, I remember this. God damn it. Okay, you know what? There is another good way rather than doing simply recursion and calling pow into whatever into that. Again, we can actually use a new way, but for that, I'll need to first understand it. We know that, let's say there's a 2 to the power of 5. Okay. So we've got 2 to the power of 5. How do you do 2? So 2 to the power of 5 will be 2 into 2 into 2 into 2 into 2. Right? What if I say get me the power of these two and then multiply it with 2? What will that do? Basically just get n by 2 into n by 2 into 2. So it'll keep on going till it gets to 1. Does this actually reduce the amount of iterations? So let's see. Say we have a function that is 2, that is again we have got n is equal to 5. Okay, 5 will call n by 2 once. Okay, we'll just call it n by 2 once because we can just, and then into n, so it'll go n by 2 into, so this will be a log n algorithm. Okay, so what do we have? So we know if n is equal to 0, return 1. Okay, because that will be the end case. So then else we'll have to create an else. We'll create a long half power which is equal to power n by 2 comma, so in the else condition I'll have to even write an if n by 2 is modulus 2 is equal to even or odd, or I can just get the long first, right? Yeah, I can just get the n by 2 first. If n is equal to even, is n is equal to 0, then go ahead and say half power return half power into half power mod d, typecasted to int. Maybe that might be the it. Else then we go ahead and do +1. So what am I missing here? I think I will have to do log n by 2 percentile d here as well. You know what, let's give it a shot. Okay, I do not know my modular arithmetics properly, so this is going to be a disaster for sure. So what is the ending condition? The ending condition is for sure if n is equal to 0, then return 1. 1 else. Now we will add this in there. Long half is equal to pow, yeah, pow n by 2 uh, n by 2 comma, oops, n is b, right? So it's x, n, and d, right? 2 power 3. Okay. So we'll just write b is equal to 0. So x to the power of n. So x will still say a, comma, b by 2, comma, c. This is very freaking unintuitive. Into, so half power, so I have to just get the power to the half, right? So okay, how do you write the power function? Okay, power function would be shit. Into 2, yeah, into n itself, into a modulus d, which will be c. Okay, what does this do? So it'll go ahead and say, hey, a right now is 2, so get me 2 to the 2 by 2, so 5 by 2, which is 5 by 2, which is equal to 4. What? 2 2s are 4. What's wrong with me? So 2 1, so it'll return 1 to the power of 0 is 1. Am I bad? Because it'll never become. Okay. If b is equal to 1, okay, so we get a, which returns 2 into 2, which will be 4, right? So half power. Okay, so let's take 2 to the power of 5. Okay, 2 to the power of 5. So we know b is 5. So in the first case, it'll go ahead and say, hey, so I'm setting power back to 5 by 2, which is equal to 2. So in 2 by 2 is equal to 1. We know 1 is equal to, so it'll return 2. Go back, 2 into 2, which is equal to 4. Fuck me. Let's just go call stack time. Okay, call stack 2 to the power of 5. Okay, function is pow n, sorry, pow 2 comma n by 2 comma d. So this doesn't matter. In the first call, it'll go ahead and say n is equal to 5 by 2 is 2, 2, and then calls over here, n is equal to 1, returns 2, 2, then over here 2 will come 2 into 2 is 4, and yeah, so this should return 2 into 2 is 4. Okay. Actually, why am I even doing that? Okay. I know I don't need this bit. I'm gonna keep it here just for the sake of debugging. Okay, what does it do? If b is equal to 0, it returns 1 because anything to the power of 0 is equal to 1. If b is equal to 1, then it'll return a. Okay, because anything to the power of 1 is equal to a. So a will go over here and say if it's just 2 to the power of 2, what will it do? It'll go ahead and return 2 to the power of 2. It'll go over here, it'll be n by 2, which will be equal to 1. 1 will go over here, 1 will return 2. Simply 2 into 2 is equal to the half power. Yes, is that equal to half power? No, it's equal to full power, right? 2 to the power of 4, what will that do? Okay, 2 to the power of 4 will send 2 to the power, so we'll send 2 first and then 1. Okay, so that means the 1 will return 2, then 2 to the power of 2 is 4, which is, of course, yeah, that's half power. Okay, we should be good over here. So the full value will be 4 into 4, which is whatever, 16. 2, 4, 8, 16, yeah. And then if it's 5, then it'll just add another one, or else it'll subtract another one. We should be good over here. Do I know modulus arithmetic? No. Damn it, Java. Why you like this? What? What? Anything to the power of 0 is equal to 1. Yes. Then b. But even 0 to the power of. But 0 to the power of 0 is equal to 1. See? Wait. 0 power 0. Yeah, it's equal to 1. That's so stupid. I'm right. Fine. This is so stupid. I'm not even gonna lie to you. Wait, wait. X to the power of n, so a to the power of b, right? Yeah. Mod c. Huh. Oh, do I have to actually? Oh, fuck. Am I? Do I have to do that? Okay, you know what? Let's just take a call on this. Let's just take a call on this. Let's talk to someone. Figure this out. You do not know modular mathematics properly. I'll have to go to the modular mathematics again, which is sad, but I'll get through it. We'll go through the classes again once we are on that whole scene. It is not absolutely fun, but yeah, it's fine. We'll take some help, figure it out, and see what I'm doing wrong, and hopefully it'll be good. By talking to him, I'll just probably Anish. Okay, I'm gonna pause the music. Hey Anish, how's it going?
Yeah, hello. Hello, can you hear me now?
Yeah, I can hear you. I can hear you. Don't worry, I just joined. I just joined, so it's not your
Oh,
fault.
okay, okay.
Sup?
Yeah, I'm fine. So what issue you're facing with this particular problem? Like with the modular thing?
Yeah, I think I don't understand modular arithmetics the way I'm supposed to. So I first of all, also I don't see the constraints, so I didn't know there will be minus to deal with.
Yeah. Like if there are no constraints given, then just simply assume that you have been given the extremes of the constraints.
Okay, so I'm guessing minus and plus 10 to the power of 9 because an
Definitely.
int has to be returned. So what I did was pretty similar to what I was taught. You could say I took a long, I took a half, where I would send the recursion through an n by 2, basically stack it up to n by 2s because we know that half into half will save a bit more time. It'll create a log n,
Definitely.
etc. And I think the only thing I could have done wrong, and then I'm returning the type of int with a full value modulus c.
Okay, let me just have a look at the code once again from the
No,
beginning itself.
no problem.
If A is 0, okay, number itself is 0. If B is 0, it is 1. If B is 1, then return A modulo C. Okay, fine. Log half is equal to power of A comma B comma C into A. Okay, this is Java. Okay, so in line number 11, multiply 1L before in line number 11,
Hmm.
write down 1L into power. So that we, the entire expression, at the beginning, log half is equal to 1L.
One, sorry, what?
L. 1L, long. L for long.
Okay, over here.
Yeah, write down 1L
Okay.
into.
Sorry,
Make
that's
that
yeah,
a
yeah,
small capital. Yeah.
yeah.
So
I
that we
got.
are typecasting that entire expression to long itself.
Okay.
Because power is integer, right? So
Yep.
we'll multiply integer into integer. So that's why we convert the entire expression to long
Hmm.
and take it And we don't need to multiply into a here, right?
Mm-hmm.
Into a is not required because we
Yeah.
are only taking the half value.
Okay.
Into a is not required. Yeah,
Okay.
yeah. And write down whole modulo c, like give a closing bracket and the opening bracket at the beginning.
Okay.
Yeah. Now
So
this thing seems fine. Now
when do we
full
multiply
value.
then?
Uh, in case of odd, full value is half into half. Absolutely correct. If the modulo is zero, then we'll return full value modulo c. Okay. In line number 18, just write
Mm-hmm.
down that full value is equal to, like, we will not
Mm-hmm.
multiply here, yeah, because full value is in long currently, right? So
Oh, right,
full
yeah.
value is equal to full value into a,
Okay.
whole modulo c.
Okay. Okay.
Yeah. Now we will return the same thing in line number 15.
I don't think that's the error that, but yeah, with the int, right? Int typecasted.
Yeah, full val.
Okay. So,
Yeah. Now
so right
let's
now
just
my
have a
wrong
look at it.
answer is because of the -1.
Okay, okay, okay. Like we have not handled that thing.
Yeah.
Uh, like if uh,
Where does it multiply then? That's my question.
okay, when do we multiply into a, right?
Yeah.
Like in case of or, like
Only in
just
case
check
of
the else
odd,
part.
because over here I just thought because you'll have to like power will just go ahead and return a and then not multiply with anything. So unless because that's what I'm saying. So say
Yeah, so it will return you a to the power of b by 2 value, right? So if you
how
multiply half into half, so it becomes a to the power of b.
let's just take an example of the stack. Sorry, I'm making you go through this. I know because I don't
Mhm.
understand this part.
Yeah,
So say we are taking the stack over here, all right? Um,
okay,
okay, we can just do this. So we are in this function
hmm,
sending like this function calls say if the num if let's say 2 to the power of 5. Okay,
okay,
we are sending 2 comma and by 2 would be over here 2, all right,
correct, correct.
and we are sending
Like
this
here the
to
power is odd, correct?
yeah,
2 to
yeah,
the power of 5.
yeah, that's yeah, I know how to handle that case. I'm just saying, and then it'll become 2 comma 1, and when it's 2 comma 1 it will go ahead and call it'll just basically this will just basically return 2.
2 comma 1 will return 2.
Yeah,
Absolutely correct.
yeah, and this will return 2 back here,
Yes,
and then it does not multiply with anything, so wouldn't this also return 2,
correct.
and then this will also return 2?
No, this will return 2 into 2.
Yeah, 2 into 2, so which will be 4.
Yeah, and that is actually full value is that is what storing.
Yeah,
Half value into half value.
so yeah, no, the full half, so half over here will be 2, right?
Yeah, half would be 2. Yes.
um
Full would be 4.
so half into 4, f but 4 into then 2 will be 4 to the 8, right? So 2 to the
No,
power of
but we are not
4 is
multiplying into
16.
2. But we are not multiplying into 2 here.
No, I'm just saying full value. Okay, so full value is 4, right?
Yes, correct.
So full value is 4, but 2 to the power of, so but we are supposed to get 2 to full value should be 2 to the power of 4, right?
Yeah, so it will go
2,
back to that
4,
function, right?
8,
Which
16.
called,
I'm sorry, which function? Okay, so let's say so okay, it so pow called this one n by 2.
yeah.
It called it 3 times and it got 2. But because it's not
Yeah,
multiplying,
let's just assume we need to calculate the power of 2 to the power of 5. Okay.
mhm,
So half would call 2 to the power of 2, right?
yep,
So, and what will half store? 4, correct?
yep.
So now my full value becomes 16.
4 4 is 16, yep.
Yeah. So we can see that and b is 5, right?
Mm-hmm.
So that we'll go to the else part,
Okay, yeah, got it, got
and
it.
then in the else part we are multiplying into 2, so now it becomes 32. 16 into 2, 32.
Okay, okay, let's take. Okay, can we take 6 as an example? I think that will be a better
Okay.
idea. Okay, 6 by 2 is 3. Or then also it will go to 2 only, and then it will return 2, 2, 2. It will get the value will be 2 again, right? No, wait.
Hmm.
2, 3, 3 by 2, 3 by 2 is 1. Yeah, so it will again return 2, 2 and go back to that thing. It will become 2. Half will be equal to 2. Then 2 into half will be equal to 2. Full will be equal to 4. Wait, what am I missing? Wait, hold on. I'm confused because I don't see a multiplication happening here, right? So I'm getting confused because it'll just return 2 if I'm here. So if I reaches here, it just returns 2. So that means every power before that should return 2, right?
Actually, I'm not getting your point.
One second. I'm so sorry. I cannot, I'm not able to explain it properly, right? Okay, let's just take half. Okay, this is the function, right? One second. This is the function. Uh, one second. Okay, the first time, now let's take b is equal to 4. Okay, b is equal to 4. Okay,
Hmm.
so this b, so that means when this is called, in this next call, this b will be so the first call will say 4 by 2, okay, which is equal to 2.
Okay.
Okay, we call this again, which is like, so this is calling this one, which will again 2 is equal to 1. Okay, which will,
Okay.
this will return 2 back here,
Okay.
and that will return 2 back here. So half will be equal to 2, right? So full will be equal to 4, because half into half.
Uh, this it will return 4, right? Because from 1 you return 2, and that
Okay,
again will multiply, right?
where will it
Half
multiply?
into
Where is
half.
it
Full. Check.
uh,
Full. Half into half. So that return 2, right? Earlier. So we will do 2 into 2 here.
oh, because it still has to go here. I'm so stupid. Okay, I got it. I got it. I'm so sorry. Because we're still
Yeah.
returning this. Okay, I got it now. I get it now. I'm so sorry.
Yeah.
I'm so sorry. Oh, I feel embarrassed now.
Now, yeah. Now, what you need to do is that we need to typecast. We can't use this original function because
Mm-hmm.
all of three are in integer, right? Int A, int B, int C,
Mm-hmm.
right? So I will suggest you to write one more pow2 kind of function,
Okay,
okay, and just copy paste this entire code over there.
but with long.
Exactly.
Okay, let's take.
There's one extra closing bracket. Yeah.
Yeah, sorry. Okay, let's just X marks this. Let's. Okay, you know what? I should just start typing. Public static. Do we need static? No. Public long polymorphism works, right? I'm just hoping that polymorphism is fine.
Hmm.
Okay, and we'll just go ahead and do this.
And here, yeah. So here we will not return int of that. We will not typecast here. Yeah. Scroll up.
Mm-hmm.
So inside it, just declare three variables long x, y, z. Yeah. So x would be 1l, like x would be long of a, 1l into a.
Oh, into right.
Hmm.
Can I not static cast? Like
Yeah, you can do that also.
long.
Yeah. Long a. Similarly, y. Here itself, take the modulo of x is equal to x modulo c. X is equal to x modulo z. Sorry.
Oh, you want me to take the modulus here as well?
Yeah.
Oh, can I not just do here only then?
But we have not done with c here, right? Like z is storing, right?
Yeah, yeah.
So x would be x is equal to x modulo z.
Oh, okay. Oh, we can also do this then.
Okay.
Sorry. I know I'm being a bit pain. This is just lazy.
We will not do modulo z in the power itself. It's not required in for y.
Okay, so this is no longer required.
No. That's fine.
Hmm?
Scroll up. In line number 6, it's not required because b is the power.
Oh, right.
Yeah. So after this line, we will do like if x is less than 0, we'll put that condition.
Hmm.
Then we'll do x is equal to x plus z.
Okay, can I know why?
Yeah, if it goes negative, then we add the modulo to it to make it positive.
Oh, because we are trying to um, range it in between the positive value of. So we're ranging it between 0 and modulus, right?
Yes.
Okay, so I have to. So whenever there is a modulo given, I have to assume that we're trying to modulus it between 0 and 3, like the positive
0,
number.
2, 2. Yes.
0 and the modulus. Okay, got it.
Yeah. Then now we'll call that function return. Will return power of it.
Uh, Wait, sorry, we don't have to return.
Not here. Like after doing that, if
Okay, what? Uh,
yeah, with that long variables. Fine.
should be good.
Yeah.
So we got a helper function. All right, got it. Oh, converting long to int. Typecast it.
Yeah.
Okay. All right, that kind of helps out. Yeah, I should probably go through the modulus classes again, shouldn't I?
Yeah. Yeah. Like a bit of thing. Other than that, it's fine.
Okay, so what? Okay, so any of these that are unrequired because we've
No,
already
like it's
checking.
fine. It's fine.
So this is fine. The only thing I found a bit irritating is 0 to the power of 1 should be 0, right? 1 should be right. 0 to the power of 0 should be 1, right? For
Zero to
some,
the like 0 to the power of anything is 0.
no, 0 to the power of 0 is equal to 1, I think.
No, it's undefined.
Oh, it's undefined?
Yeah.
Because I googled it and I was like, okay, it's usually taken as 1. Okay, makes sense.
Yeah.
Sure. Thanks a bunch, man.
Yeah. Okay. No issue at all.
I I cannot believe I fucking forgot that the whole it actually has to go through the rest of the goddamn function. How did I forget that? That's so stupid. I was like, oh yeah, 2 will go into multiply and this is the full value, and this is oh shut up, man. Just shut up. Alright, next. Okay, give a number A, we need to find the sum of digits using recursion? Or sum of digits. Okay, how do we do this? Sum of digits we know it's pretty simple. We need to get a digit is equal to n modulus 10, and next iteration is equal to n by 10. Okay, now how do we get each? So if say digit is 10, um I think, can we do we need to do all of that? Okay, so what is the ending condition? If n is equal to 0, nope, that won't work. If n is less than 0, that will work. So n is less than 0, just terminate. Okay, makes sense. There are no digit left to get. So the ending condition will be if n is less than 0, else uh, return uh, solve n by 10 plus n modulus of 10. Should be fine. Okay. If n is less than 0, if n is less than 0, what do I do in return 1? Wait, what will be the termination condition for this? Shit. I didn't even calculate that. Okay, let's take 12 as the answer. So, 10, 1s are 10, 2, and by 2 is 1. 1 divided by 10, zeros are 0, 1. 1. So it'll be n by 10. So over here, well, 1 by 10 would be 0 point something. So it has to return something, right? Um, hmm. Can I just return 0? Because in that case, you just don't have to do anything. Because we're already doing plus n. Yeah, I think that should be fine. That's absolutely fine. Hmm. So stupid. Okay. Actually, if n is equal to less than 0, shit. Less than 0, what the fuck is wrong with me? Or equal to 0. I mean, yeah, it'll just return 0. So just return 0. Else return n modulus of 10 plus solve of n by 10. This should be it. It's A, isn't it? Fuck it. I'm gonna do that. I need to stop assuming that the parameter is gonna be n. Not that it matters, but correct answer. We're good. We got above 300. That's awesome. That means we have done for the day mostly. But let's give it a check if it's a magic number or not. If it's said to be a magic number, if some of its digits are calculated till a single digit recursively by adding the sum of the digits after every addition. If a single digit comes up to be 1, then the number is a magic number. Aware? You have to do this in order of n, by the way. Is it what? We have to just return if one digit recursively is the same, right? So if we can start from 7, 5, 5. Oh, both of them are same. Return. So if I want a numbered, so I have to just go ahead and just copy this. Alright. And rather than doing this, if n modulus of 10 is equal to n by 10, return 1. Is this it? So basically it's like current digit and the next digit before it are equal, return 1. Recursively. And there's going to be an n algorithm. It's not going to like it. Probably not. Let's do that. Okay. I'm confused. Oh, because I'm returning the wrong thing. Yeah, I'll have to get to the drawing board because I have to actually send and get the number. How do you do this recursively? I can have a separate function which basically goes ahead and gets that digit. We can do current number next, like last number, current number, and we can compare them. We can do that. So we can write a function that goes like uh, this is gonna be a bit more difficult than I thought. Ewigs. I hate this already. Okay, I can just write a particular number. I can go ahead and say, hey, um, oh no, no. Oh, All right, where were we? I needed to kind of figure out a way to figure out how to get this. So can I write a another function that basically just checks the next? So we can just write a check current next. God. If a single digit comes out to be 1, then it's a magic number. A number is said to be a magic number if the sum of its digits are calculated till a single digit recursively by adding the sum of the digits. What is the explanation? Sum of the digits is 28, 10, 1. Oh, are you serious? Wait, the sum is different than I thought. Okay, so n is greater than 0. Yeah, I can just. One second. I can just take this. Okay, let's do this. And then if simply if n is less than 10, return return 1. If n is less than 10, return 0. Else solve sum of n. So what does it do? shit. Is there an extra one? Two, three. One second. was stupid. I forgot to change the name of the function, which is being called recursively. Ah, beautiful. It's fine. We did it. We got 471. We're 21 days in. Okay, maybe in the afternoon I'll be able to come back in and go through some of these problems. That'll be good. Some of the locked ones. It'll actually go ahead and I might practice a bit more recursion directly with recursion 1 and recursion 2. I would like to go ahead and do that, but I'm hoping to, at least on Sunday, get a bit higher. That would be fine. That would be fun. Oh, my neck. Oh, my neck.